All right. Here I have actually a little bit of the board notes from last Friday, the 1st of November, and I have some notes from today, the 6th of November, which is Wednesday. Last Friday we talked about IP addressing, and we talked about binary number system. I reviewed the base 10 number system, and then we went and we talked about this particular layout. Anything raised to the 0 power is 1. And so we listed the binary system. Anything 2 to raise to the first power is 2. 2 raised to the second power is 4, and so forth. And so we listed those, and then we wrote an IP address underneath there. And in this example, we've got one group of 64, one group of 4, and one group of 1. Which would give us 69 base 10. And the reason we need to be able to convert is to be able to recognize addresses more quickly, because the computer just remembers or just looks at the ones and zeros. Okay, so then we have another one here in which then that one comes out 172. And we work that backwards. We started with 172. We took a group of 128 out, a group of 32, a group of 8, a group of 4. And if you look at that, and you can see then where each of those are in the address. We talked a little bit about comparison here of private addresses converted to public addresses. We talked a little bit about that. We talked about getting an address from DHCP. Public address here at the college, and our private address. This is the workstation the instructor uses in PC 229. So that was our introduction to addressing, and then we set up a little bit of work that the students can do. We talked about the network part of the address compared to the host part of the address, and the subnet mask that determines that. And then this was an example the students could work on before Tuesday on their own. And they would remote in to do this. Everybody had their own device, and I had the devices connected to this multi-layered switch that had multiple addresses in it. So that was on their own type of work in order to do that. And then today we did an ANDing. We took this address that was from my workstation, and then we took the mask and we ANDed it. The object here doing this ANDing was to show that what we ended up with after ANDing this, we ended up with the network part of the address right here, which turns out to be this part of the IP address, IP version 4, 16 prefix bits. So routers they do an ANDing to get the network part of the address. We did a little bit of practice on converting addresses. So I took this group, and I said, well, if we had this group, by the way, the 207 came from our public address that we use here to go out. And what the students did was they wrote out this first one, 204, and this is the first octet. We don't have the other octets behind there. And then they did 205, so one here for 206, and this would be 207. And the interesting part was this is the same. And so out on the internet, if this was all in one general area, the routers on the internet all over the world could forward packets to that basic area. Kind of a funny thing to think about at first, but later on you'll start to realize that becomes crucial in order for the internet to function. This part of the addressing here, you can see how a router, if this was in the same vicinity, these addresses, they're the exact same prefix bits. You'd really only need to look at those 6 bits rather than the rest of the address to get it to a certain area. And that's it for now. We talked a little bit about the class of addresses, and I went through this little scenario in which if it's a class A address, there's a 0 right there, which means it's going to limit those addresses from 0 to 127, 255, 255, 255. Even though this is legacy now, it's still good to understand how it used to work. And so all the B addresses had a 1 there, which means they would be at least 128.0.0.0 all the way up to this one, which would be 191. Dot 255, 255, 255. And the next class C address then, that one would start at 192. And then D would start at 224 and E at 240. And then we talked about the group that's taken out of there that are private addresses. We did this little simplistic example down here in trying to show that if this PC was going to go to this PC, the router would only need the network part of the address to forward it over there. So if you were to take a look